Summing matrices. Okay, I have a matrix here, and I want to sum the columns. So I want to sum of the columns. Now, obviously, 2 plus 3, 5, 4 plus 0 is going to be 4, and negative 6 plus 5 is negative 1. Didn't need to sum them, you're saying, with a fancy matrix thing, but obviously this applies to any size matrix, and they do ask you questions, and I'll show you some in a minute, that show that we do actually need to understand what we're doing. So as we said, 2 plus 3 is 5, 4 plus 0 is 4, negative 6 plus 5 is negative 1. That's our answer. So that tells us if we want the answer 5, 4, negative 1, well, remember, this is a 2 rows by 3 columns, and this is a 1 row by 3 columns. Well, we need to have our pretty nose and our lovely eyes matching up like this, yeah? So what numbers do we need to make that work? Well, we need to have a 2 here, and that gives us our pretty nose defined. And we need to have a 1 here, because then the answer for a 1 by 3 is actually what our answer we got. So we know then that the size of the matrix we need to solve this, and this is quite a common kind of question they ask, is a 1 by 2. Now let's write a bit of rules about this. So to sum, which means add up, columns, you need to have a row matrix of, and it's just ones, yeah, of ones, and row before column, yeah. That'll make a bit more sense when we do it the other way around in a minute. Now, if we just double check everything here, let's say, look, if I have this row by this column, that's 1 times 2 plus 1 times 3, that's 5. It works. Let's try it on the next one. So it is the same row by now the second column. So that's 1 times 4 plus 1 times 0. That's 4. And if I do one by the first row by the third column, I will get 1 times negative 6 plus 1 times 5, which is negative 1. All right, this time we're going to sum the rows. So 2 plus 4 plus negative 6 is 0. 3 plus 0 plus 5 is 8. And that's our answer. Now, quite often a question will ask you to find out what this guy looks like. Spoiler alert, it's already there. But let's show how we back calculate that. So we know this is a 2 rows by 3 columns, and our answer is 2 rows by 1 column, rows before columns. But we also know we've got to have our pretty nose. So we need to have a pretty nose here. So we know that this number must be a 3 because the two numbers need to be the same for our pretty nose to make sure that the matrix answer is defined. And we know the answer is a 2 by 1. So it's got to be a 2 by 1, which means it is a 2 by 1 like that. And if you put that all together, you end up with a 3 by 1. So to sum the rows, we need a column matrix of ones. And we also know that this time, remember, it's rows before columns. So that means this guy comes after. Before, the row was first, the row summing matrix, but the column summing matrix comes second. And let's just double check all that maths works. If you think about it, it is 2 by 1, 4 by 1, negative 6 by 1. So that means you get 2 plus 4 minus 6, which is 0. Beautiful. Then if you do the exactly same thing for the second one, 3 times 1, 0 times 1, 5 times 1, that's 3 plus 0 plus 5, which is indeed 8, and you get the right answer. This is from 2018 exam 2, And so what is the cost of one journey on section G? $2.87, because we just, read it off the thing. So cost for G is $2.87. Put the dollar sign. It says cost. So if you just put 2.87, it's quite likely they wouldn't give you the mark. Part 2 is saying write down the order of matrices. So remember, it's rows by columns. So that's 3 by 1. Okay, don't write that bit in there, but just to remind you, rows by columns. Then it says, one day Kim travels once on section E and twice on G. His total cost for this day can be found by the matrix M by C. So we're going to find out what M is. Well, we want to sum the columns, but this time we actually want to do some multiplying. So we've got this once, but we've also got this twice, and there's nothing for F. So if we want to write down M, we're going to be doing a row matrix such that we're multiplying, E, F, G, all right? So we want to multiply E by 1, we want to multiply F by 0, and we want to apply G by 2. So M is 1, 0, 2, and that will sum up those things nicely. So remember, the row sums the column, but in this case, it wasn't just, we didn't want to just add them. We also wanted to do a bit of multiplying here. So it's a bit of a trickier question. Don't forget, that's not part of the answer. The answer is just 1, 0, 2. Nice little trick here. They didn't mention F. You got to make sure you put the 0 in the middle. Quite a lot of people would have done 1, 2, 0 as a mistake. Okay, this is from 2017 exam 2, question 1, part C, part II. Now, there are actually also a little bit of a trick here because it talks about rolls and sandwiches. There are also, if you read the rest of the question, some pies. So this is the pies, this is the rolls, and this is the sandwiches. So it says we only want the totals for the rows and sandwiches. So we don't want the pies. So we don't want the pies, we want the rolls, we want the sandwiches. Okay. And that was the trick of this question. It was worth 1 mark. I'm sure a few people went 1, 1, 1 or gave it in the wrong place. Amazingly, still some people did a 3 by 1. Crazy talk. So remember, if you want to sum columns, you use a row matrix. They even told you the order of it. The main trick here was realizing that for the pies, you need a 0. So that's pies, rolls, sandwiches. Okay, so we want the product. If you didn't know, product is times. So we're going to multiply 2 things together, but we want to get the total number of coins and the total value of coins. So we want 2 numbers. All right. So let's just check everything's defined. This is 1 by 4 and a 4 by 1. So it's defined, but the answer is only a 1 by 1. So no. B is 1 by 4, and this is a 4 by 2. So it's defined, and it does give us 2 numbers in the answer. This is 1 by 4 and 4 by 2. So defined does give us 2 numbers. This is 1 by 4, 4 by 1. Defined, but only gives us a 1 by 1 answer, so it can't be true. And this is 2 by 4 and 4 by 1. So defined, and it does give us 2 numbers. But if we just want to get the total number of coins, which is this one, we just want to multiply this by 1, 1, 1, 1, right? And the only one that does that is B. So the problem is with C, it's multiplying, that's the wrong thing to multiply the 1 by 1 by 1 by, and the same mistake is made in E. It's multiplying this and it doesn't work. So both of those don't work, and that's why B is correct. And then if you look, so the first row by the first column gets us the total number of coins, and then if we do the first row by the second column, you're multiplying 15 by 5, 32 plus 10, 48 times 20, and 24 times 50. That would actually get you the total value of coins. So the answer is B. Now this is from a much older exam. This is from 2010 exam 1 question 4, and it says we want to work out how to sum 2, 5, 4, 1 plus an 8. Yeah, I know you can do it in your head, but which one is the correct way to do it? Your instinct should say it's between A and B, not C, D, and E, because remember we want to do sum, and summing it normally involves a bunch of ones like this. It does not involve the identity matrix or the identity matrix or the identity matrix. So all C, D, and E are wrong. All right. Now, which is it? A or B? Well, a couple of ways to look at that. This is 4 by 1 times 1 by 4. So yes, it does multiply, but your answer is 4 by 4. So it's not A. And if you check this one, remember, we've got 1 by 4 times 4 by 1. Yes, it's defined pretty nose, and the answer is 1 by 1, because the sum is one number. It's the total, isn't it? And remember what we said, if we want to sum a row, you multiply by a column. Okay, this is from the 2015 exam 1, another older question. I just thought I'd bring it up there. And it says the number of adult and child ticket prices for 5 performances of a stage show are shown in the table below. Tables equal matrix. Which one of the following matrix calculations can be used to determine both the total number of adult tickets and the total number of child tickets purchased for all 5 performances? So we can see that there's going to be a matrix here. I'm going to have to zoom out and show you the answers. It's quite a big question. All right, first thing to notice is they've taken that matrix and they've transposed it. I'll put a little T for transpose, but there's nothing to give away in all of that because they've all got that matrix. So although that might seem a bit tricky, just remember the rows become columns or columns become rows, it's the same thing. But we can eliminate B and C because those aren't summing matrices. So we know it's between A, D, and E. But we also know we want total number of adult tickets and total number of child tickets. That's only 2 numbers. So our answer is either going to be 2 by 1 or 1 by 2. All right. So this is, if we just check the size of this, this is 4 by 1 times 2 by 5. If I said 5, 4, that's 5, isn't it? I can't count. And so not a pretty nose, can't be done. And then this is 1 row by 2 columns, and this is 2 rows by 5 columns. So it can be done, but it gives us 5 numbers as the answer. And it looks like it's E, but let's just double check that. Again, if you want to sum rows, you multiply by a column, as we said earlier. So this is 2 by 5 and 5 by 1. Yes, we've got a pretty nose, it's defined, and the answer is 2 by 1. We don't even have to work it out. We just know that we need an answer that's going to just give us a 2 by 1 or 1 by 2 matrix. In this case, 2 by 1, so the answer was E.